So this video is just going to cover the 5 main aspects of trigonometry, and it's broken down into 5 separate parts, but usually in the exam they're going to combine a couple of them at least. So trigonometry is to do with triangles, hopefully that bit's obvious, and the part that says metry, that's to do with measures, and what it means is that it's to do with finding either lengths or angles within a triangle. So here's the 5 main sections. So the first one is Pythagoras, which is just for finding side lengths, and this only works for right angle triangles, and we label them A, B and C. The second one is also just for right angle triangles, but this time we're finding an angle, or we're using an angle to find a side, and we label them H for hypotenuse, O for opposite and A for adjacent. And then these next two are when we don't have right angle triangles. So you might have a triangle like this, just a scalene triangle, and the sine rule is when we've got pairs, so an angle and the opposite side, and then another angle and the opposite side. And then the cosine rule is just the one that's left, so when we've got a scalene triangle and we might just want to use this angle and these sides to work out one of those. And then the last bit is using trigonometry to be able to find the area of any triangle, because when we've just got a normal right angle triangle we can use base times height divided by 2, or even if we're given the perpendicular height then we can work that out as well. But when we've just got a scalene triangle and all we know is about lengths and the angles and we don't know the perpendicular height, we've got to use this other formula, which is a half AB sine C. And then we'll just at the end have a look at some exam questions so you can see what they might do to pull that all together. So hopefully this will be the most obvious one, but I'm just going to show you how to do these 2 questions just so you're exactly sure how to set them out. So I'm going to label the sides. A and B are always the shorter sides, so it doesn't matter which way around, and C is the hypotenuse, which is always opposite your right angle. And then we write down the formula. Always do that, it shows an examiner exactly what you're doing, and then substitute your values in after that. So 5 was A, 24 was B, and then we're just going to work these 2 out. So 5 squared is 25, 24 squared is 576, so we're going to add those 2 together, which gives us that C squared is 601. And then we would just square root that on our calculators to get the answer. Remember at the end that we're talking about centimetres, so we want to include the units on there as well. This next one is pretty much the same apart from we're not working out C this time. So I'm going to label my sides A, B and C. I'm going to write the formula exactly as I did before and substitute the values in. And this time B is the one that I want to find out. So again, I'm just going to work out what I do know. 4 squared is 16, 5 squared is 25, and then to get x squared on its own I need to get rid of this plus 16, so I'm going to subtract that from both sides. That's going to leave me with 9, and then I can square root that to get a 3. And that's it. So now we're on to SOHCAHTOA, which is basically just trigonometry but for right angle triangles only. So like I said before, we're going to label H is the hypotenuse, the longest side, O is the one that is opposite the angle we've been given, so that's this one here because it's opposite the 35, and then A is adjacent, which just means next to the angle. So what I then need to do is think about which 2 of these sides I'm bothered about. Now we're not given any information about A, and we don't want to work it out, so that's the one that I'm going to cross out. I'm left with O and H, which as you can see in SOHCAHTOA go with the S, which means we're using the sine function. So you should find that on your calculator. And we've got sine of the angle, which is 35, equals O over H, so x over 17. And then I want to find x, so I'm going to multiply both sides by the 17. And just type that into my calculator to get the answer. And so we get the answer 9.75 centimetres. Okay, just one more just to show you how to find an angle. So again, H is the longest side, O is opposite the angle we're interested in, and A, again, we're not interested in that one. So we're going to be using sine, keep it nice and simple. Sine x equals O over H, so 66 over 79. And to be able to work out an angle, we've got to use the inverse function. So we press shift and then sine, and it comes up with sine to the -1, and then we can use the fraction button to type in that fraction there and get our answer, which is 56.66. And this time it's degrees because we were finding an angle. Okay, so now we're up to non-right angled triangles, and the first one we're going to use the sine rule to find a side length, and then the second one we're going to use the sine rule to find an angle. And you can tell that it's the sine rule because we've got matching pairs. So if you look at this first diagram, I've got an angle and the side opposite, and then another angle and the side opposite, and because I've got two pairs like that, the sine rule is going to work. So for this first one where I want to find a side length, I'm going to use this version of the sine rule, and that's because my side lengths are on the top, and so it's going to be the easiest way to rearrange the formula. So I'm not interested in all three parts, I just want the bits that I've been given, so I'm just going to label this triangle. I'm going to call this one A, so that's little a, and then this angle B, and so that one's little b. And then I'm not really bothered about C. I could work out the angle if I wanted to, because I've got the three angles in the triangle, but I don't know what side C is, so it's not going to help me at all, so I'm going to just get rid of that part for now. I'm going to substitute everything else that I know. So P is the side that I want to find, and the angle is 32. And then I've got 21, and the angle that's going with that one is 95. And remember, I'm finding the side length, so I want to get P on its own. So I'm going to multiply by the denominator. So I get 21 sine 32, all divided by sine 95. And I can just use the fraction button and type that in all in one go to get 11.17. And remember, I'm working out a side length, so normally you would have units with this as well, so I'm just going to assume that those are centimetres for this one. And then the other version, when I want to find out an angle, is I basically just flip the rule upside down. So I'm going to do the same thing. I'm going to label A and B, which means this is little a and little b. And then I'm going to flip this formula upside down, so I've got sine A over A equals sine B over B, and substitute in the values that I've got. So I've got sine 100 over 5.1 equals sine B, and that's what I'm wanting to work out this time, divided by 3.6. So I want to end up getting this B on its own. So the first thing I'm going to do is multiply by the 3.6. So I'm left with sine B equals 3.6 sine 100 all over 5.1. And I'm going to type that into my calculator, and then what I'm going to do to get rid of this sine function and to get B on its own is I'm going to use the inverse sine, so press shift and then sine, and then I'm going to use the answer button so that it's as accurate as possible. And when I type that in, I should get 44.04 degrees. So that's the sine rule, nice and simple. Okay, so the cosine rule can get a little bit more complicated. Firstly, because you've got to remember the formula correctly and it's not as obvious as the other ones. But secondly, just because you've got to make sure you're labelling your triangle right and that you're rearranging things correctly. So this is the way that I would do it. Even if the triangle is labelled like this one, P, Q and R, I want to label it so that I've got A, B and C. And I'm always going to label A to be the angle that I'm interested in. You'll see why in a second. So I'm going to relabel it. Doesn't really matter which the other two are. And then I've got that this side here, which is the one that we're wanting to figure out, is A, this one is B, and this one is C. And because we're working out a side length, the version of the formula that we want is a squared equals b squared plus c squared minus 2bc cos a. Gives you a clue the cosine rule involves cos. I know some of you have made mistakes before and put sine in there, so just try and remember that cos goes with the cosine rule. So I'm going to substitute the values that I know. So x is what we want to find out, b is 4, c is 13, and then this is the important bit. If you don't want to make mistakes, then you need to use brackets. So 2 times by b, which is 4, times by c, which is 13, times by cos of the angle, which is 70. And I'm just going to type that all into my calculator, and if I've got time, I'm going to type that part into my calculator at least 3 times and make sure that I've done that correctly. And this is what I get. 149.4299. Okay, and then I just need to find out what x is, so I'm going to square root that answer. I'm going to use the answer button so that I make sure that I get full marks, that I'm not rounding too early, and my answer is 12.22, again with the units. Now the second one, I'm actually finding out what an angle is, so the version of the cosine rule that I want to use is this one. Cos A equals b squared plus c squared minus a squared all over 2bc. Now if you're confident with rearranging the first formula, then that's fine, but if you're not confident that you can rearrange that accurately, then you're going to need to try and memorise both versions of the cosine rule. And then I'm just going to do the exact same as what I did before. So the angle that I'm interested in is A, the other two, doesn't matter which way around they are, and then I'm going to substitute the values in. Again, this is the part that I'm going to type into my calculator a couple of times and just make sure that I've got the right answer. Use brackets where you need to, and this is what you should get. 31 over 57. Now obviously if you've got a decent calculator, it'll give it you as a fraction like that, which is more accurate. And then remember, we've found cos A and we want to get the angle on its own, so we need to use the inverse cosine function by doing shift and then cos, and you could just use your answer button in there to make sure it's fully accurate, and you're going to get the answer 57.05 degrees. Okay, so the final way that we can use trigonometry is to find the area of a triangle, and we always want the exact same setup we've got here, so we want two sides and the angle that is between them. So if I knew the side QR instead of PR, then it's not going to work. It has to be the two sides and the angle that is between them. So what I'm going to do is I'm just going to write down the formula, which is a half AB sine C. And for this, I don't even really label the triangle. I just know that my sides are A and B. So I've got half times by 4 times by 13. And the angle is C. And as long as I make sure that at the beginning I've got the angle which is between the two sides, then those are going to be the right values. So I can just type this in. So half of 4 is 2, times by 13 is 26, and then type that straight into my calculator, and I get 24.43, and because it's the area of a triangle, it's going to be centimetres squared. So that's actually quite simple. So now what we're going to do is just look at some exam questions so that you can see how they can make these things more difficult. So here's your first one. So this time we've got two triangles, and I notice first of all that they are both right angled triangles, so I'm probably going to be using either Pythagoras or trigonometry, and I might be using both. So I'm going to start off by looking at what they want us to work out. They're wanting us to find the perimeter, and when they say the below triangle, I'm assuming that they mean the whole triangle, so both of these separate triangles put together. So I need to be able to work out this length here. I need to be able to work out this length, and I need to be able to work out this length. Now straight away, the one that's most obvious to us is the one on the left. So if we look at this triangle on the left, let's call this one x. If we want to work out x, then we've got two sides in a right angled triangle, so we can use Pythagoras. And because that's not the end of the question, I'm just going to leave that as root 260. I'm not going to round it for now. So then, once I've worked that one out, I'm now going to look at this right hand side of the triangle. And I've been given an angle, so I know that this is going to involve SOHCAHTOA somehow. So the first one that I'm going to work out is this side here. I'm going to call that y. And what I've actually got is, if I label the triangle, I'll do it in red for you. This is the hypotenuse, this is the opposite, and this is the adjacent. And for now, I'm not bothered about the hypotenuse, I'm working out y. So I'm bothered about O and A, which means I'm using tan. So I've got tan 40 equals, it's got to be O over A, so it's going to be 8 over y. And when I want to calculate y, what I need to do is do 8 divided by tan 40. And that's just from rearranging the first line. And so I find out that y is equal to 9.5340287. Now I've just kept quite a few decimal places in there so that my final answer is really accurate. And then the very last bit is to work out this final side, which I'll call z. So this time, again, I'm using this right hand side triangle. I've already labelled it up in the right places, but this time I'm not bothered about y, I've already worked that out. I'm bothered about these two, O and H, so I'm using sine. So I've got sine 40 equals O over H, so that's 8 over Z, and so just in the same way, I've got that Z is equal to 8 divided by sine 40, which gives us 12.44579. So remembering what the question wanted, I wanted to find the perimeter, so I need to add up x, y, z and the 14. So I'm just going to add up this square root of 260, the 9.534 and the 12.44, and then I'm going to add on 14 to that. So my total perimeter is 52.1043341. And usually in the question it will tell you to round that to something like 3SF, so we'll leave it as 52.1 and it's in centimetres. Okay, so this one I'm not actually going to go through. If you want to have a go at it just for your own practice, that would be great. It's just to show you it's exactly the same as the last type. It's two triangles put together. You're going to have to work out this side first. I'm going to just label that Y there. And then you're going to have to use that in this other triangle where you've got two sides and an angle and you want to work out the third. So that one's going to be the cosine rule. So if you want to practice that one, then come and get me to check it. Okay, so this is quite a tricky question involving area of a triangle because we've also got some algebra in there. So I'm just going to talk you through this one. As soon as we're told that it's about the area of a triangle, I'm going to set up my equation, which is a half AB sine C, and we've been told that that is equal to root 300. So I'm just going to make sure that I've got the right things in the right places. So I've got a half times by x plus 3 times by sine 60 equals root 300. So I'm going to do two steps in one now. I'm going to times both sides by 2 to get rid of this half, and I'm going to multiply out this first lot of brackets. And then this one was from a calculator paper, so I can just divide both sides by sine 60. So I'm left with x squared plus 3x, and then when I type in 2 root 300 divided by sine 60, I get the answer 40. So it's looking like a quadratic. I'm going to get it all onto the left hand side, and then let's see if we can factorise it. So they need to multiply to make 40, so I'm already thinking 8 and 5, and I want to end up with a 3, so it's going to be a plus 8 and a minus 5, and from that I could get that x is minus 8, or I could get x is 5. And because we're on about side lengths, it's got to be this second solution, so I'm going to stick with x equals 5 centimetres. But the question wants us to find out the length of AB, it wants us to find this side here. So now that I know x is 5, I know that B is 5 and that A is 8, and I already knew the angle to begin with, so I can now use the cosine rule. So I want this version. And I want to work out what A is, and I want to just substitute in my numbers, which are 5 squared, 8 squared, and then brackets, remember, 2 times by 5 times by 8 times by cos, and this time it's 60. So I'm just going to work all that out, and it works out really nicely to get the answer 7.